All right, we should be done with number 13 or getting close to it at this point. I'm going to go through and show you some markings that if you don't have on there, I'm going to ask you to add on. I kind of mentioned this in our last class, though. We're starting in chapter 2 and things are getting a little bit more technical in this chapter. So expect that to happen. I want to give you a little warning, and I'm hopeful that you can avoid some of the frustration that my past students have had at the beginning of chapter 2. So here's my warning. There's a lot of vocab in this chapter. And if you start getting behind on your vocab now, it's going to snowball into a big problem by the end of the chapter. Okay. So I need you to know what vertical angles are. If you need to take a second right now and look at your notes that we took on Friday to remind yourself what vertical angles look like, at this point, you've got to know what those are. And when you see them, you've got to be able to recognize them pretty quickly. Oh, those are vertical angles. I need you to know, what do we call it? What a straight angle pair looks like. Also, there's some vocab from chapter 1 that's going to pop in here. Okay, and if we get to that and you don't know that information, that might be something you might want to copy into those extra notes section of your packet, which is on the last page, second to last page. All right, so I'm going to tell you that my students in the past sometimes have struggled when they get midway through this unit because they don't take the time to actually work at memorizing what these terms mean, and more importantly, what the properties of them are. Okay, so do we know what vertical angles look like? And do we know what's special about a pair of vertical angles? What about their size? Do they add up to something or are they equal to each other? Vertical angles are always equal to each other. You need to know that. If you don't know that right now, if you weren't sure when I asked those questions, you need to spend some time with it. Maybe make some flashcards if that's worked for you in the past. Make a vocab list. Do what you got to do. I'm not going to force you to do one thing or another. That's kind of what middle school is all about. We force you to try a whole bunch of different ways of learning, hoping that you'll figure out what works best for you. We're in high school now. It's your job to pick one of those and do the study you need to. I need you to know this stuff, though, okay? Because we're going to just keep adding on to it. By the end of this unit, there'll probably be 20 or so different things like that you got to know. You got to keep them straight. And if we can't start making sure we've got the few down now, when I add another 4 or 5 in the next class and another 3 the class after that, like I said, it's going to get out of control, snowball out of control. Okay, so here we go. The question asks you to determine, are these two angles going to be the same or complementary or supplementary? And I'm also going to add on, I'd like you to justify your reason for this as well. Okay, so I'm going to add on a little bit extra information to my answer here. But what do you think? Are A and B the same, or do they add up to 90, or do they add up to 180? They are supplementary. Did you write supplementary for part A? And underneath that or next to that, I would like you to justify it. How do we know that those two angles add up to 180? Use the vocab that you're going to be expected to use on the test. If you write flat line on the test, you're not getting any credit. I asked you to have that sheet out. There's a good reason for that. What is special about A and B? It's a straight angle pair. Right? And our notes. Can you, by the way, can you write where it says straight angles here? Can you change it to straight angle pair? Straight angle pair. Sometimes I call these a linear pair, but I need you to know that terminology. I need you to, when you look at this, you need to be able to see that and say, oh, look, there's a straight line. And here's two angles that are coming together to create that straight line. You need to be able to see that. Okay? All right, how about part B? What can we say about C and D? They're the same, yeah. They're the same, which means we can put ticks on them. And how do we know that C and D are the same? Because they are, finish it, you got this, you got this. Congruent means they're the same. Why are they congruent? Because they are vertical angles. Okay. When you see those angles that are across from each other, the name for those types of angles are vertical angles. What's special about them is that they are the same, they're congruent. All right, F and G here. Add to 90, add to 180 are the same. What do you think? Oh, no, go for it. Complementary? You're right. Can complementary angles add up to 90? And how do we know they add up to 90? Because of that, right? So the symbol. There's not really a name for that symbol. It's a perpendicular symbol, I guess. All right, this next one, we have real trouble with this in first period today. Let's see who remembers their facts from chapter 1. H and K are the same, add up to something, add up to 90 or add up to 180. The same, that's correct, they are the same. Can anybody tell me how they know that they're the same? What do you think? So the two sides of the triangle are congruent, which makes it a triangle, an isosceles triangle. An isosceles triangle also has another property. We put it in our pink packets, and that is that the two angles are congruent. Okay, I need you to know this. Okay, and if you didn't, then this might be something you might want to add into your extra notes. But in our last packet, we had a spot where we talked about isosceles triangles, and we talked about how the base angles are congruent. Okay. So when you see an isosceles triangle in this class, we're done with chapter 1. That's where we learned that. I need you to know that those angles are congruent. You should mark them immediately. As soon as you see an isosceles triangle, mark those angles. How do we know to mark those angles? Because it's an isosceles triangle. Okay. On your homework for tonight, which we will have time to get to in a little bit, you're going to have to then combine this with writing an equation. So I want to practice this a little bit too. We don't have anything to write an equation for, but I want you to pretend and kind of write the format of the equation. If we have supplementary angles, is that going to be the style of equation where two things are equal to each other, or where two things are adding up to something else? Two things are adding up to. So just draw me a little sketch of an equation. Some blank box plus some other blank box equals. Do we know what they would add up to in this situation? 180. Oh, good. Good for you guys. So if I gave you a problem where this was 2x plus 5 and this was x minus 3, you'd be able to stick those in those two boxes and solve that equation, right? All right, what would your equation look like for part B? Blank equals blank this time around, because those two angles are equal to each other. Can you kind of make me a pseudo equation for parts C and D, just like we did for parts A and B? Just with some blank boxes, decide, are they going to add up to equal something? Or are they going to equal each other? If they're going to add up to equal something, write in what you think they're going to add up to equal. Write me some pseudo equations. Not the full equations. One with some blanks in it. I think part C, did you have two things adding up to something? Yeah. Adding up to what in this one? Blank plus blank equals 90. And then for part D, are we adding up or are we equaling? Blank equals blank again. Okay. Really important skill to think about what the equation is going to look like before you start writing it down. And I usually don't draw boxes. I usually draw a little, I do draw a blank though. And then I'll fill in the blanks. Yes. Blank minus 2 times star. Oh, I see. Equals 0. And what is the star representing? What will represent what now? So the star is the angle, and then the blank would be what? Oh, I like that. I would modify it slightly. We haven't learned this yet, but the angles in a triangle add up to 180, so we could do it that way. I like that you're thinking about those two angles being congruent. This would not have to be the same as these two added together. It's not always. Sometimes they are. Sometimes they are. Mm-hmm. Like if this is 40 and this is 40, then this would have to be 100. Yeah. Okay, we're on the same page. Awesome. All right, we ready to move on? I'm going to need you for this next trick in your group. So go ahead and format those groups, please. Format those groups. Huh? Where's the sheet? Yeah, I'm like going up and trying to. Gotcha. Do you want to? No, we'll make people that are kind of. You three together. You four together. We got 3 there. We got 3 there. Okay, I'm going to give you some instructions here, so we'll get into those groups and pay attention so you don't miss what you're going to do. I'm going to ask whoever in your group is sitting closer to the front desk, and don't go until I tell you go, okay? You're going to come up here and you're going to grab 2 things. There's a half sheet handout and a piece of tracing paper. Can you please grab one of these for everybody in the group? I'm a little worried about group 7 back there. It doesn't seem like anybody's paying attention to me. Okay, you're not doing it right now. You're gonna wait till I say go. Okay, half sheet of paper and a piece of tracing paper for everybody in the group. Okay, then at the same time, whoever's sitting closest to that back table back here is going to grab 4 different color markers and a couple rulers. I don't have enough rulers for everybody in the class as long as you've got a couple. All right, 1, 2, 3, go. Gather your materials, please.
These are
Yep, absolutely. Yes, I'm gonna put it right here so you see it next time I try and type it. Then we'll get it in the grade book today. All right. Get my material set to go here. All right, so I'm going to show you what we're going to do here. You'll want to pay attention to this, and then I'm going to give you a task to work on. So in case you're curious, we're working on number 14 here, but you don't need to read it because I'm going to give you the short version. You ready? Look up here, please. Please take your tracing paper, and I'd like you to trace, and don't put it right in the middle, put it on the edge. Trace this top left angle up here on that little half sheet. You can do it with marker, with a pen, pencil, doesn't really matter. Just trace that angle. And my goal is to then color in every angle that's the exact same size as that with the same colors. So this angle right here I'm making mine orange. You probably have a different color than me, but that's okay. I want to move my angle around and find some others that are the same color. Ooh, look at this one. See how that's the same size? I can tell because it matches up. I'm going to color this one in orange also. All right, I'm using the tracing paper to check and make sure the angle is the same. Look up here for a second. Am I going to color in this angle up here? No, that is clearly not the same size, is it? So can you please go through and color in all of the angles that match that one? And then I would like you to pick a different color and color in all of the angles that match one of the other ones. That's why we've got 4 colors at the table. If you have 4 different sized angles in that picture, you should have 4 different colors. Color in all the angles that have the same size in the entire thing, okay? Yep, you can rotate it with the translate it, just help stretch or shrink it. That wouldn't get rigid anymore. Right. This one's back here. Yep. That's gonna be on the side. I don't mind if it's plugged in, it just needs to not be visible. So put your back. Here you go. Take your sweatshirt. Outside out of mine. Thank you. So anything that's the same size should be the same color. Everything that's the same size angle should be the same color. Yeah. So you might have 2 or 3 different colors, or maybe even 4 or 5 different colors. It just depends on your picture. Okay. So this angle is different, right? Pick a different color and color in all the ones. Outside the box there, I like it. Literally. Looking good, looking good. Oh, you guys are doing so great. It makes me so happy when you get right after it. Started right away. You're helping each other out and asking questions. So you help model the exterior angle there. If you really wanted to. Good. Now, so this angle is different from all those angles, right? Can you grab another color and color all of the ones that match this one with the other one? Orange work. Good. So this one's different from those red ones. So grab another color for me. For all the ones that match. Color code. So you did yours in 2 colors. We're also colors. 2 colors. Everyone's going 2 colors, huh? How many 4 color people in here? Hey, all right. All right. All right. see here. Just another minute or so, and we're going to kind of talk to this a little bit. All right, so I'm going to show you a couple examples. Most of you did something that looks like this, right? And most of you use two colors. So this is pretty cool. I saw a couple of people. Did any of you also include these angles that were on the outside of the shape? That's pretty cool. I like that. I didn't think to do that when I did this the first time. So, but you're right. They are the same size. Now, a lot of people in my first period class use four colors. So this, all of these green ones are kind of in the upper right-hand corner, and it is correct. They are all the same angle. And the orange ones or red ones are down in the lower left-hand corner of each of these boxes. And those, it is correct that those are all the same. So is one of those better than the other? No, not at all. So they're both correct responses. This one actually is going to get to what we're going to do today a little bit more closely than this one, but they're both correct. So, all right, let me get these back to their rightful owners. And you want to get your books open to page 86. You've got four colors too. I like it. Yes. All right, so on page 86. This is why I asked you to grab rulers. You're going to want to make a pretty good sketch here. It does not have to be 100% perfect. We're going to draw this figure here. I encourage you to draw it kind of big on your notes because we want some space to be able to work with it. You've got some straight edges there, or use the lines on your graph paper. This is going into your notes. Not in the green packet yet. This is in our notebook where we do our normal class notes. If you're not going to lose it, I guess. I would be worried about losing that half sheet. If you've got lined paper, it doesn't need to be graph paper. Lined paper would work just fine. And we've got a lot of stuff to label on this, so take your time, make sure you get everything in the right places. All right, you guys got a task to do right now. If you don't get busy, you're going to get left behind, okay? Start getting that figure drawn neatly into your notes. This is problem number 15, and it's on page 86. You can use just regular lined paper for this for sure. Mine's about this big. If you make it this big, you're going to have trouble. Sure. Yeah. You drew the rectangle around it too. That's cool. It's not necessary, but what they're showing you with that rectangle is this is sort of a piece of that tile pattern that we were just looking at zoomed in with a whole bunch of labels on it. So all of you have credit for Algebra 1, right? So you learned last year, I hope, that when you get to high school math, you can't afford to miss anything, right? If you don't understand how to solve equations in first semester of Algebra 1, there's no way you're going to be able to solve systems of equations in second semester, right? Like everything builds on itself. Geometry is no different. So we have a lot of stuff going on in this chapter that relies on you knowing the chapter 1 stuff. For example, my hope is that please don't shout out any answers right now. Give everybody a chance to think about this, please. Please don't shout any answers out. Thank you. My hope is that you all know what these symbols mean here. Don't shout out an answer. Give everybody a chance to think about it. If you don't know, see if you can remember ever seeing those arrows on shapes. Maybe someplace like in our shape toolkit, which we use very heavily in the last week of our chapter 1 work. Can someone raise their hand who'd like to tell me what they mean? What do they mean, Jacob? I mean, we got parallel lines there. Did you guys know that meant parallel? Awesome. That's great. If you didn't remember that, that's okay. But that's an example of something that right now you got to know that. We went over that. We used it. From here going forward, you got to know when you see those arrows, that means you got parallel lines. All right, I'm going to introduce some new vocabulary to you. These are parallel lines. This line that's cutting through them is what is called a transversal. A transversal is just a line that cuts through 2 other lines. A transversal. You're going to want your tracing paper here for this next thing. I can find mine. Transversal. All right, go ahead and take your tracing paper and put it on top of that top intersection there. And I would like you to trace off angle A. Just angle A. All right. And I would like you to find me some other angles in this picture that would have the same size as angle A. Okay, so go ahead and move that paper around. You can do any of our transformations, rotations, reflections, translations. Find me some more angles that have the same size as angle A. Yeah, why don't we do that? I think that's a great idea. Who suggested that? Yeah, I think that's a good idea. Let's put a single tick mark there at A. And then, or a single arc rather around A. And let's do the same thing on all of the other angles that would be the same as A. So what have you found? Give me another angle that's the same size. Z is the same size, so we'll put an arc around Z. What else? D is and W is. Any others? Okay. All right. Move that tracing back to A. We're going to do the same thing, but I'm going to introduce one new rule. We're looking for angles that are the same size that we can match up with that. But this time we can only do translations. No rotations, no reflections. How many other angles can you match this angle up on top of? Only doing translations. Remember, translations mean you can move, but you cannot rotate and you cannot flip it to reflect it. How many angles can you find that match up just using translation? Without rotating or reflecting. Translation is literally just moving it, not flipping it, not rotating it, just moving it. Transformation, the word transformation encompasses all of those different things, translations and rotations and reflections. How many were you able to find? 2 of them? One of them. There should be only one. What is it? What does A go with? W. A goes with W. So you see how if I take A and I slide it right down this transversal, I get to W. That is our new special pair of angles. Those are called corresponding angles. Can you please write this down for me in your notes? Corresponding angles. And these always come in pairs. The first pair that we found was angle A and angle W. Angle A and angle W are corresponding angles because I can slide from one of those angles to the other one without doing any rotations or reflections, just translation. Can you see if you can find me some more corresponding angle pairs in this picture? I'm going to challenge you, and I'm going to give you a little bit of a spoiler alert. There are 3 more pairs. Can you see if you can find me all 4 total pairs of corresponding angles? What else? So those are points. The only angles, there's only 8 angles. I could draw some more lines and then you're right. That will be 360 degrees. Yeah, and you're right. And technically, we're going to line. There is a line here. So then there will be 4 more angles here. There are more than just the angles out there, but with the ones that we've marked. But the ones that we've marked so far. So we got A and W. Yay! Everybody's favorite group here. Ooh, free commercial for you there, A and W. Send my check to the high school. All right. What else? B and X. Do we agree on B and X? B and X. Writing it down. What else we got? C and Y. And finally, D and Z. All right. Now, all right. So do we kind of get the idea of what what 2 corresponding angles are? Hey guys, I need your attention. Please don't miss this. This is, by the way, I should have warned you about this too. Corresponding angles is the one that people are going to forget. This is the one that you're going to have the hardest time remembering out of all the stuff that we do this week. Okay. I feel like we got a pretty good idea of what they look like and how to find them. Can anybody describe to me in words how you spot corresponding angles? How would you describe it to someone? What do you think? I like that. So an angle that matches another one just by translation. And we would have to add along a transversal, but we can make that work. Alex, how would you describe it?
If you take one set of angles, then pick Tuesday, then choose one angle, they would be the exact same. The exact same set of angles, just the graph.
So you're kind of envisioning this intersection and this intersection being the same thing. Like this is just a copy of this one. And so we know A and W are corresponding angles because they're the same. And what's the same about them? I'd say they're in the same place, right? They're kind of in the same spot in their intersection. When I look at this, a lot of times my students have success if they look at this like a street map. Right? Think about downtown Ferndale. What are two streets that run parallel to each other? Main Street and what? What's the one that's where the dentist office is? And oh man, we need Google Maps here. Well, and obviously, yeah, my geography's always been pretty bad, but I haven't lived here that long. Hang on a second. Google Maps to the rescue. All right, here we go. All right, let's check this out. Can you guys see this okay? Let's talk about Main Street and Vista, just in this area right here. Would you agree for these couple of blocks that Main Street and Vista are parallel to each other? And what is my transversal? What is my transversal? 3rd Avenue is the transversal. Now, if I'm looking for corresponding angles, I'm kind of looking for two places, two shops that are in the same position. Like this Anytime Toffee gift shop, which I don't know that I've ever seen before. It would be, oh, it's new? Okay. So is it pretty good? So this place right here would be corresponding angle at the subway right there, right? Because it's on the same corner of the intersection. The Ye Old Barber would be corresponding with the gallery at 3rd and Main. So sometimes it helps my students to think about these in terms of like a roadmap. All right. So it's about time for us to get some good notes into our packet. Oh, before we do though, there is something special about corresponding angles. That's why we talk about these things, because they have properties. Vertical angles are congruent. Straight angle pairs add up to 180. What do you think is true about corresponding angles? A and W, this angle right here and this angle right here. What would be your conjecture? What do you think is always going to be true about corresponding angles? They measure the same. Any other conjectures? They're the same angle, measure the same. Another word for that would be congruent. You think they're congruent? That is a fantastic guess. It's not correct. So close. So close. So close. All right. Can I get you to look in your book? And we're not going to draw these out. Let's just talk about them. But I need your attention. You don't want to miss this. This is really important part about corresponding angles. On the next page, number 17. You don't need to worry about drawing this out. Just look in your book, please. I see most people have their books open in front of them and they're paying attention and following along with us. We're looking at 17A. Focus your attention on that 135 and tell me which of these angles over here would be the corresponding angle. What do you think, Amir? X is corresponding. They're both kind of in the upper left position here, aren't they? I could slide that 135 over and it would land right on top of X. So do you agree, Amir? Do you agree with our conjecture that they're going to be the same? Yeah, in this case, X would be 135. You're absolutely correct. However, I want you to look at part B. What is the corresponding angle for 135 here? Some people are saying there are none, and that is not correct. There is a corresponding angle for 135. What is it? What is the angle that is in the upper left-hand corner of the intersection over here? X is the corresponding angle for 135 in this picture. It is. Because if I started at this location and slid down the transversal, I would end up in the same spot, right? but the angle's not the same. That's why I said we needed to modify our conjecture. All right, so these are corresponding angles, okay, but they're not equal. These are corresponding angles, but they are equal. What's the difference between these two pictures? That's the key. Someone say that again louder. If the lines are parallel, then the corresponding angles are going to be congruent. But if the lines are not parallel, then those corresponding angles are not congruent. Okay. Corresponding angles are not always congruent, only if the lines are parallel. Okay. So look at part C. Notice that 135 and X are in the same position. They're in the upper left-hand corner of their intersections. And the lines are parallel. I can tell you in part C that X is 135. In part D, I don't see any corresponding angles, not that are marked. So we can't do that one just yet. All right, so let's go to our notes. We got to keep this in mind. First of all, what is a corresponding angle? And then what are its properties? These are the notes that I wrote. You're welcome to copy these, or if you want to kind of branch out on your own and do it differently, I color-coded mine. So this is on that second page of your packet, in the corresponding angle spot. And I underline this, but I think I'm even going to put a box around it because it's really important. Only if the lines are parallel, corresponding angles are congruent. So once your notes are done there, I'm going to give you one last challenge here before we get into our homework. While you're copying down the notes or getting your own notes down, I want to preview this challenge. So at the beginning of the year, remember how we talked about how a lot of times the problems that we do in geometry kind of resemble a court case. And your job as a geometer is almost the same as a lawyer's job in a courtroom. You have an idea of what is the truth, but your job is to convince someone that that is correct, to communicate, to use logic, to build an argument that leads from something that you do know for sure to something that you think is true. And this is in geometry, this is called proof. Can I get you guys to pause the side conversation? This is super disrespectful. Yes, thank you. This is called proof in geometry, and I want us to try our first one. Now we're a long ways from being ready to do proofs on paper. Okay, we have a lot of terminology and vocab and properties to learn before we're really going to be good at this. But I think this is a good opportunity for us to just kind of get our hands a little bit dirty with the concept of proof. So I want you to look at this paper. And if you want to go ahead and copy this down, you can, but you don't have to, as long as you can see it. I forgot something here. I have 2 lines in a transversal, and I've marked off some angles. And I want you to look at this picture and tell me, do you feel like A and C, angle A and angle C, are going to be the same size angle? Do you feel like they are the same size angle? No. All right, then I want you to think about how you could convince someone, how you could prove to someone using what we know already. So you might want to keep your green packets out with those notes that we just took. Using what we know already, how could you combine some different pieces of information to put together a solid argument that A and C are going to be congruent? By the way, without tracing paper this time. Okay, no, I just want you to think about it, maybe talk it over with your group, and I'm going to get some different ideas, and then we'll check it out. Protractors, no. No, we're not using any measuring tools. Only the facts that we know and the properties of things that we know. Is a big hint. Think about the vocabulary terms that are on your sheets. What do you see in the picture? Got some ideas. How about your neighbors? Let's around some ideas. Got some ideas? You're the gatekeeper of the ideas? All right. We got some ideas? Yeah. So you guys think you're ready for proof? No. Mhm. Well, we're not going to use tracing paper for this. I want you to be thinking more along the lines of the stuff that we put into our packet right now. Okay. So if you walked into a courtroom and you had this picture and you had our green packet with the notes we've taken so far, how would you convince a judge that A is definitely the same size as C? I'm going to get a couple people's input here, and then we'll see how we go. You want to get us started, Jacob? Say again. The two lines are parallel. That is an important piece of evidence that I would definitely want to introduce if we were going to talk about this. You want to go ahead and add on? You want to say the whole thing? Say the whole thing.
Since both lines are parallel on the
These guys? Yeah.
And since A and B are corresponding angles and B and C are vertical angles, A and C are the same.
You got all the pieces there. We might need a couple little details added in there, but I can tell that you're seeing it. That's awesome. What else can we add in?
When they're like almost hit each other, they're the same.
Okay, vertical angles when they're opposite each other, they're the same. In fact, we could cut that down and just say straight up vertical angles are always the same, right? Okay, so we're seeing vertical angles here. Excellent, which is a huge part of your proof there. What else? A and B are corresponding, and you're making the claim that A and B are the same. What additional piece of information do I need to have to do that? A and B are angles. The angles can't be parallel. The lines are parallel. You're right. All right, we are so close, guys. You're doing awesome. I'm really excited. It's really cool. One more thing, Alex. What would you like to add? Nobody. No, it's not. So it's not a 100% accurate. Yeah. No, we're not trying to disprove anything yet. We will talk about disproving, and that has like a whole different arc to it. All right, so let's lay it out piece by piece. Okay. If I were starting this up, I would probably start with, I don't know, I might start with B and C because we know they're vertical. We don't need any other information to tell us that angle B is congruent to angle C. So if this were a proof, I would write that. That would be my first step. And my reason, and when we do proofs, we always have to have a reason. How did we know that B and C were congruent? The vertical angles. And vertical angles are always congruent. That's a property of vertical angles. And then the other piece that most of you are seeing is you were seeing the corresponding angles, right? Now, corresponding angles are great, but corresponding angles are only congruent if what is true. So we would have to say that the lines are parallel first before we broke out the corresponding angles. Otherwise, the corresponding angles doesn't mean anything. Corresponding angles are only congruent if we know the lines are parallel. So I break out the parallel lines first. My reason for that would be given because it's in the picture. So given means it was information that was provided to me as part of the problem. And then I could say that angle A is congruent to angle B because if lines parallel, corresponding angles congruent, we'll learn all the different shortcuts for writing that out later on. But that's basically what we learned today. And then finally, I would be able to say, okay, if A is equal to B and B is equal to C, that means that A is congruent to C. And this is something called the transitive property, which we'll talk about later as well. That is super impressive, folks. As a class, I think most of you are able to kind of put together that proof in your head. We'll get into the details of how to build a proof later on, but that's where we're headed with this, okay? So as you're working through the work, please have these notes out, okay? My first period class, people are asking me questions left and right, and my first response was, look in your notes, okay? I will gladly answer your questions, but if you haven't checked your notes yet, then I'm going to ask you to do that first. Homework assignments is 19, 20, 21, 22, and 23. And we got about 10 minutes to work on that. Let's utilize that time well. I know you will. You guys always do.